This is one of the most oldest and most popular line clipping procedures. So generally how is this most popular algorithm? What it does is generally the method speeds up the processing of line segments by performing initial tests that reduce the number of intersections that must be calculated. Now, every line endpoint in a picture is assigned a 4-digit binary code called a region code that identifies the location of the point relative to the boundaries of the clipping rectangle. So basically what it does is, suppose there is a line, we assign a 4-digit binary code, okay, called region code to each endpoint of that line, and it identifies that region code is identified by the region where the point lies. So now how to assign the code? So we have to remember this format: top, bottom, right, left. So in this format we are going to assign the code. If the line endpoint is in the top left position from the clipping window, suppose this is the clipping window and the line endpoint, one of the line endpoints lies in the top left corner of the window or top left of that window. So what we do is we assign the code 1001. So basically we assign 1 for top, we assign 1 for left. So that's why it is in the top left corner. So we assign 1001 and we assign 0 for bottom and right because it's not there. So similarly we assign the codes to all other positions. For example, the top middle one, so it's in the top position, yes, 1. It's not in the bottom, yes, so 0. It's not in the right, so 0. It's not in the left, so 0. Similarly for window, it's neither on top nor below nor in the left nor in the right, so it will be, everything will be 0 0 0 0. So this is how we assign all the 9 area codes to this chart based on the window. Now once we determine the region codes for each endpoint of a line, we can find out, first thing, that whether the line completely lies outside the clipping window, or the line completely lies inside the clipping window, or the line partially lies inside the clipping window. So now to find the above information, what we do is we perform logical AND operation on the area codes of the two endpoints of the line. If both the endpoints lie outside the clipping window, suppose both the endpoints lie outside the clipping window and the logical AND of those endpoints is not 0 0 0 0, we have to find out whether it is 0 0 0 0, then the line completely lies outside the clipping window, so we don't have to worry about it. What we have to do is we just have to perform logical AND operation. If both the endpoints lie outside the clipping window and the logical AND operation does not give us 0 0 0 0, then we don't have to worry about it because the line completely lies outside the window. If both the endpoints lie inside the clipping window, then also we don't have to worry about it because both endpoints lie inside the clipping window. So there is no question of clipping that line because it is completely inside. So the whole line will be included. You don't have to perform any operation. And the third condition you have to check is if both endpoints lie outside the clipping window and logical AND operation results 0 0 0 0. This one is the one, guys, that we have to check. Then the line lies partially inside. Remember, it lies partially inside the clipping window. So what we have to do is we have to perform the operations to find out how much line lies inside the window after clipping the line. Now to understand better, let's solve an example and we'll understand the procedure. So this is the example. Let A, B, C, D be a rectangular window. So this is our A, B, C, D rectangular window, which is a clipping window. Okay, so the coordinates given for A are 20 20, okay, 20 20, B is 90 20, C is 90 70, and D is 20 70. So we have assigned it accordingly over here. Now what we have to do is we have to find the region codes for the endpoints and use Cohen Sutherland line clipping algorithm to clip the following lines: P1 P2 with P1 as 10 30. So we have assigned P1 over here 10 30. Just draw a graph randomly to get an approximate idea where the point lies. So 10, 30 over here, and P2 is 80, 90. So it will be over here. Now draw a line between P1 and P2. As we can randomly guess or approximately guess that P1, P2 partially goes through the clipping window. But to confirm it, what we have to do is we have to take a we have to perform logical AND operation on this both the area codes of this both the endpoints, and we can get the confirmed answer there. And the second line is Q1, Q2, where Q1 is 10, 10 over here, and Q2 is 70, 60. So which is over here, which lies inside the clipping window, as we can see, because the clipping window is extended till 90, 70. So fine, let's get to the solution now. First, draw a diagram like this. This is a simple graph diagram that we have drawn. Now let's check the line P1, P2. Now P1 is 10, 30, P2 is 80, 90. Now clipping window is 0, 0, 0, 0. Yeah. And P1 lies at the left of the window. Okay. So area code of P1 is 0, 0, 0, 1. We can see P1 lies at the left of the window. So it's in the middle. So it is neither on top nor in the bottom nor on the right side. It's just in the left of the window. So it will be 0, 0, 0, 1. Top, bottom, right, left. Okay. And P2 lies at the top of the clipping window. So its area code is 1, 0, 0, 0. Over here you can see P2. It lies on top of the clipping window. It's neither on the right nor on the left. So its area code will be 1, 0, 0, 0. Okay. Now let's perform the logical AND operation on P1 and P2. So 0, 0, 0, 1 and operation 1, 0, 0, 0. That is going to give us 0, 0, 0, 0. Yes, it is confirmed that line P1 and P2 lies partially inside the clipping window. Now, since it lies partially inside the clipping window, what we have to do is we have to use the formula of slope to find out the position of P1 and P2 dash, that is P1 dash and P2 dash, because after clipping what will exist in the window will be P1 dash, P2 dash, that is a new line which is part of the line P1, P2. So that will happen after clipping the line. So what we have to do is we have to find the locations or coordinate positions of P1 dash and P2 dash. How we are going to do that? First we'll find out the slope. Now what is slope? Slope is y2 minus y1 upon x2 minus x1, where y2 and x2 are coordinate positions of P2 and x1 and y1 are coordinate positions of P1. So we perform that operation, that is 70 minus 30, that is y2 minus y1 upon x2 minus x1, that is 90 minus 10. What we get is slope as 0.5. Now we know the slope of line P1 P2, that is 0.5. Since P1 P2 dash, okay, is a part of the line P1 P2, so the slope of that line will obviously be the same. So now we'll have to find out the coordinate positions of first point, that is P1 dash. Since P1 dash is a point on P1 P2, slope will be same, yes, as mentioned. And the x coordinate of P1 dash will be 20 since it is on the line AD, as we can see in the diagram over here. This is our P1 dash. It lies on the line AD and the x position is already known, that is 20. So we know the x coordinate of P1 dash. All we have to find out is y coordinate of P1 dash. How we are going to do is, let's see. Now, so we have to find out the y coordinate of P1 dash. Let's again use the formula of slope. We know the slope already, that is m1. So again we do y2 minus y1 upon x2 minus x1. But now y2 and x2 will be the coordinate positions of P2 and x1 and y1 will be the coordinate positions of P1 dash. Remember, it's P1 dash this time, and m1 is already known. So 0.5 is the slope that is known. 90 is y2 minus y1 we have to find out, that is the y coordinate of P1 dash. 80 minus 20, that is x2 minus x1. Now when we calculate, we get 90 minus y1 upon 60 is equal to 0.5. Y1 we get as 60. Therefore, the coordinates of P1 dash are 20, 60. This is how we find out the coordinates of P1 dash. Now similarly, we'll find out the coordinates of P2 dash. Since P2 dash is on line DC, its y coordinate will be known. So y coordinate will be what? 70. How? Just go on top and check the diagram over here. It's over here. Now DC, on this line we know the y coordinate, it is 70. So P2 dash y coordinate we know, it's 70. All we have to find out is the x coordinate of P2 dash. So let's go over there. Now let's use the slope formula again. Okay, m1 is equal to y2 minus y1 upon x2 minus x1. This time y2 and x2 are the coordinates of P2 and x1 and y1 are coordinates of P2 dash. Okay, so 0.5 is the slope again known. 90 minus 70, this time we know the y1 because it is on the line AD, so it will be 70. We don't know the x1, so 80 minus x1, we find out the value x1 is equal to 40. So now we know the coordinates of P2 dash, that is 40, 70. Okay, now we have to consider the line Q1, Q2. Now Q1 lies outside the clipping window and its code will be 0101 as it's in the bottom left of the corner. Let's take a look. Now this is Q1. As we can see, it's below the window and it's on the left side of the window. So obviously the code will be 0101. Top, bottom, right, left. Remember the formula. How to remember the coordinates? It's 0101. So that is for Q1. Now Q2 lies inside the clipping window. So the coordinate positions of Q2 will be 0000. Sorry, the area code will be 0000. So the line partially lies inside the clipping window, as we can perform the AND operations over here below. Over here we have performed the AND operations. We get 0000. So the line Q1, Q2 lies partially inside the window. Now after clipping, we'll have line Q1 dash and Q2. Let's look at it. Now after clipping, what is going to be left is Q1 dash and Q2. Okay, so now we'll have to find the coordinate position of Q1 dash. Now to find coordinate position of Q1 dash, we first find the slope. m2 is equal to y2 minus y1 upon x2 minus x1, where x1 and y1 are Q1 coordinates and x2 and y2 are Q2 coordinates. So slope is 60 minus 10 upon 70 minus 10, that will be 50 upon 60 or 0.83. Now as Q1 dash lies on line AD, its x coordinate is 20, as we had seen in previous line also. It lies on AD, so we know the x coordinate, that is 20. Now only thing that we have to find out of Q1 dash is its y coordinate. So let's see. 0. Now what we do is we again use the slope formula over here. Now we know the slope of the line, so it is 0.83, and we know the x coordinate, but we don't know the y coordinate. So what we do is 60 minus y1 upon 70 minus 20, that is the x coordinate of Q1 dash. Okay, then we perform the same operation. 0.83 we multiply with the answer of this, that is 70 minus 20 is 50, that is equal to 60 minus y1, and we get y1 is equal to 18.43. This is how we find out the coordinate of Q1 dash is 20, 18.34. So this is how we perform Cohen Sutherland operation, line clipping operation. If you have any doubts or any problems, please watch the video again. If you have any queries, do put it in the comment sections below. Thank you guys for watching. Please do like, subscribe and share.